Dear friends, this is my tutorial 1 in ChemDraw. So in this video I'm going to tell you how to predict NMR spectra in ChemDraw. So this is the sigma Aldrich reported this proton NMR C13 NMR spectra. So in the compound name is 4-hydroxy-2-methyl acetophenone. This is the case number. So they predicted that C13 NMR in CDCl3 and DMSO D6 solvent. So these are the corresponding peaks. So this is the solvent peak DMSO D6. This is CDCl3 solvent peak. Others are corresponding to the carbon atom in the molecule. So down is the proton spectrum of this compound. So I will show you how to predict using NMR, and we will also compare. So first we will open ChemDraw. So we can draw the molecule. So type oxygen, here OH. Okay, so this is the system. So we are going to predict the NMR, C13 NMR and proton NMR of the spectrum. So first we will predict C13 NMR. So how to predict? So just go to structures in the ChemDraw and predict C13 NMR. So this is the C13 NMR of that molecule. So you can also compare with this. So if you see this one with the reported sigma Aldrich reported one, so you can find everything the same method. The near to 200 you can see the one peak, and 160 you can see the one more peak, and here 140, near to 140 you can see one, and other two is 122, 140, 3 peaks is there. So this is 122, 140, these 3 peaks, and one more peak 100 to 120, one more peak is there. Okay, if you see here come 2 peaks is there, near to 20, 20 and 30. So this is 20 and near to 31 peak is there. So this peak already I told, this is solvent peak for DMSO D6. This is CDCl3. So this things is clearly match with that the sigma Aldrich spectra. You can also compare your experimentally synthesized compound with that using ChemDraw to match the NMR. So then next we will see the proton NMR spectra. So you can minimize this. So again we can select this, already selected. So go to structure, you can predict the proton NMR shift. So this is the proton NMR shift of that molecule. We can also compare with this one. So if you look this spectra with this one, so near to 10, so one peak this is there, near to 1, so 7 to 8, this is 7 to 8, some peaks is there, signals, 2 doublet is there. So near to 6 to 7, so some peaks is there, and you can see 2 to 3 also similarly the signals is observed. That means this proton NMR is clearly matching with the reported one. So you can, this is the chemical shift value. So if you click this, the blue color will highlight here. This is OH corresponding to OH peak. So this is this CH peak. So like that you can also check your signals 6.81. So this is 2 CH3 peaks. Okay, like that you can compare. So if you have any compound synthesized, so you can draw the structure and make that proton and C13 NMR compare with your experimentally observed NMR chemical shift. So that's all. So thank you for watching my video. If you like my content, please like, subscribe and comment and share, and also click bell icon. Thank you for watching. Thank you for your time. Please like, subscribe and share and comment. Thank you once again.